Welcome everyone to another live streaming from Bone Studio live streaming. And today is a very special live streaming because I want to show you the new thing that I implemented. Well, not me, because the programming was done by Stefan Werner, that is here with us watching the live streaming, so I can be I can avoid being nervous. Okay. That's okay. It's enough. So, what's the streaming about tonight? So tonight for me, the streaming is about why do we have a custom build at Bone Studio? Why do we have a custom build at Theory Studios? Why do Tangent Animation have custom builds? Why do any studio may or should have a custom build? So for starters, I'm going to show you what do we have in our build, what do make the build special, and what do we use in the build. So let's start. Okay, first thing first, what I saw in the tweet was the viewport denoising feature. And this is a new feature. This is not in master, and it's not going to be in master for some time. At least I think it's not going to be for 2.82. Correct me if I'm wrong, Stefan, but I think it's not going to be for 2.82. And that is because it lacks a few features. In fact, in my opinion, it only lacks one small feature. But let's see how the feature works. So let me go to this. So my face is out of the screen, and we have this scene. It's a very simple scene, and we can start rendering, and you are going to see how cycles is kind of weird. If you don't know what's happening, this is because you don't know our build or the Theory Studios build. So I'm going to disable that feature for a moment, and here we have, okay, we have a standard scene with Suzanne. Now we go to performance, and we enable OIDN minimum samples. So if I put here, let's say, one sample, for example, this is what happens. So we have viewport denoising. And where is the catch? Let me increase the samples for the viewport, for example, 1000. Where's the catch? Okay, there is a catch. The only catch right now, the only problem right now is that it only works with CPU. If I enable the GPU compute, it's not going to work for the time being. Okay, we hope we have this working with the GPU, but right now it's not working. Why? Well, for starters, this is because it's Intel OpenImage denoiser. So for starters, it's implemented in the CPU, and we don't have it running in the GPU. But this is very, very cool. And as you can see, the result gets refined over time. So in the same manner that the samples increase, the refinement increase. It's awesome. It's very, very great. It's really great. Let me show you this with a more complex scene. Let's check this scene. And it's really, it's very awesome. It's very awesome. This is in speak, so it takes a while to load. And also I'm going to show you later one new, it's not a feature, but it's kind of a bug fix. It was not exactly a bug, but it's like a bug fix for the light collections. So let me configure this to properties, and let me put this here. Okay, that's it. So we can get this scene, that is a much more bigger scene. We are going to make the region, whatever you call this, region, whatever you want. And I'm going to put CPU, performance, and I'm going to leave 16 samples. And let's start the render. So it takes a while for this scene to start. What CPU are you using? This is very fast. Yes, this is very fast because I'm using the Threadripper 2990WX. So 64 threads. It's super fast. And here we have, it's amazing. It's really cool to work with this kind of feature. It's super, super cool. So if we go and we reduce the area, for example, let's take just, I don't know, this part of the scene. It's going to be super fast. And you can see how things are continuously refined. Okay, try some depth. Let's go and let's try some depth of field. So we are here and select camera, and let's enable the depth of field. So depth of field, and let's the autosave to save, because this scene takes 1.8 gigabytes, so it takes a while to save. Okay, depth of field, focus distance 10 meters, and okay, let's put focus distance at the TV, for example, and 0.4. And here you have depth of field. It's super awesome. Thank you for this, Stefan. I don't think you know how big is this as an improvement. This really helped us a lot to work with shaders. It's super cool. Yeah, it's refining. It's refining. Nothing special about that. We can check. But the refinement process is like kind of transparent to the user, because it reaches a point where you are not conscious about the changes in the scene. I think it don't get, or maybe it gets, I'm not sure if it gets the additional passes for the rendering, like the albedo or the normal. But anyways, this is super cool. It's super cool. We can disable overlays, and that's it. Let's, for example, let's refine, let's do some crazy thing. No, let me play with the camera. And we are going to put the camera here, and let's pick another object. So for example, this. And let's reduce clip start 0.1. It's not using albedo or normal at the moment. Anyways, I think the most important thing in this kind of denoiser is not to be the most precision, but to be the fastest, to make the denoiser in the fastest possible way. And okay, we are saving again. Let me disable autosave. Let me disable autosave if I cannot remember. Okay. Bye bye autosave. So I don't care if I don't get the exact result in the texture for lighting, for example. It may be important for shading. Are you using Diddle Sobel? Yes, of course. The question offends me. It's super cool to have this in the viewport, really. Really. I've been working in this project for the last days, and it's super, super cool. So this is it. This is the denoiser. The problem is that it only works with the CPU, but okay, I'm working with the Threadripper, but I also used an i7 and a 5960X i7, so it's a pretty old CPU, and it was very fast also, so I don't see a problem with this. Of course, it could be better if it could work with the GPU when you have a low spec CPU and a high specs GPU. It could be better if it works with the GPU rendering and the CPU doing the denoising. But this is very cool. What does it look like with scrambling around 2.25? Okay. This shot or the original shot? I'm going to try this shot and I can change to the original shot later. 0.25. And where the refinement is more obvious. NFM, okay. So the refinement process is more obvious, but it's normal because, you know, scrambling distance, the refinement is more obvious. And we can go, do you want me to go crazy, Derek? Let's go crazy. Let's go crazy, super crazy. And now we have a painting, a live painting. It's super cool too. It's kind of hyper realism. I think I can use this and sell a piece of art. It's like a paint, yeah. It's super cool. This is really an amazing feature, and a really amazing feature. So right now it also works with adaptive sampling without problem. The spine strokes on the table are actually amazing. Yes. We could even use this for, I don't know, for any animation, for some kind of animation. It's like 2D non-photorealistic rendering with a path tracer, with a totally photorealistic path tracer. This is a pretty cool picture. So it's great. It's really, really great. It's amazing, yeah. It's amazing. So, okay, this is the main feature for today. This is the most important and the most amazing feature, and I was eager to show you. I'm going to upload the Windows build later after the live streaming, because I added small patch at the very last minute before the live streaming, and I'm going to show you the feature, but the feature is not currently working. So it's going to be in the build, not the denoiser. The denoiser is perfectly working. It's another feature, but that feature is not currently working for the time being. So it's going to be in the build, but it's not going to work correctly. So let me show you. This is super cool. Come on, guys, this is super cool. Okay, let's go to the next feature. So what's the next feature? The next feature, it's a kind of a bug fix for the light groups. So in the latest implementation, the implementation of light groups we had in the near past, in the latest builds, in the current build that is in graphical.org, had a problem. And what was the problem? The problem was that light path clamping was not being taken into account. So it was more or less ignored. Hi, Nacho. The clamping was completely ignored, and that was a problem because when we have a very small light, what we get is a lot of noise, and that's it. And that was not useful at all. So Lukas Stockner, I was talking with Lukas yesterday night, and he was super kind, and he was super eager to help, and he fixed this. And now we have proper light groups, so light groups properly working in the build. So let me show you the light groups. We can use this scene, but let me disable the decoration, the objects, so we get a fast render. And let me put the lights. Come on, where are the lights? Okay, the lights are out here. So I have several collections, each collection for its light, because this is for a project where we are going to, well, we animated each light separately in compositing. So here in the passes we have the light groups, the sun, the sky, the sailing. This is the sailing. Let me rename this for you. The eating table light. I don't know if it's called eating table. the living room light, the entry light, and the hue light because it's a hue, Philips Hue bulb. Am I blocking the... Ah, okay. Sorry, Pablo. Thanks. Okay. In the passes, here we have the sun, the sky, the ceiling, the eating table, living room, entry light, hue light. And now we can render this. Let me disable also the compose. Well, no, I can render with compositing. So you are going to allow me to render this to a very low resolution and a very low pass count because this is in this kind of a slow. So let's render this at 500 samples and that's it. And CPU, well, I can use CPU plus GPU and okay, that's it. Let's render this. Now we want to see light groups with painterly look. You want to see, but that's easy. We have to render with a very low samples count and use Intel Open Image Denoiser. That's it. Don't crack up a scramble. If I don't crack up a scramble, we get this crap. Don't you want the oh, of course, and the depth of field. Let me disable the depth of field. So let's pick depth of field off. And yes, I'm going to rise the scramble distance. And let's disable the adaptive sampling. And let's render again. I'm sorry, Pablo. I want to show you an actual picture, not an actual painting. So now we have the render is kind of super noisy, but this feature also helped me to discover where the noise was coming from. So since I have every light in the scene in a separate collection, I can go to render layer, and now I can go here and I have the sun, the sky, ceiling, eating table, living room, entry, and hue. So we go to the sun, and the sun is the culprit for all the noise in the scene. And it's driving me crazy. So Lukas, if you're watching this, or Stefan, if you can tell me why the sun is killing the scene in this scene, because I cannot understand this. Because if we go to the sky for 500 samples is kind of clean. So I don't understand what's happening with the sun. So wait a second, can you denoise just the sun and not? Yes, I can, of course. I'm going to do that in a minute. So we have the sky, we have the sailing light, we have the eating table light, that is this one. Okay, let me render with the decoration. It's fast enough. So let's go let's render this with the objects. I think you should turn off the multiple importance for the sound loop. I did it already and it was not helpful. It did nothing. There was no difference. Yeah, actually you should turn miss off all lights but the sun. Okay, I have not tried that. I should have asked you, Derek, but I've been so busy that I completely forgot to ask you. So let's disable multiple importance for any other light, and let's check what happens. Bye bye multiple importance. And here light multiple importance. Should I turn off? No, I cannot turn off multiple importance from the sky, right? From the world. No, that's not an option anymore. So okay, that's it. Let's see what happens. I can? How can I turn off multiple importance sampling for the world? There's no option here. It was here a long time ago, but there's no option here. Under sampling, where it says manual auto, set it to none. Oh, okay. Okay, I'll do another test later. Derek is like, Derek is Lord Odin, for the ones that don't know Derek Barker. He's Lord Odin, and he's kind of the cycles master. I think there is no one that knows so much about cycles like Derek, really. I'm not 100% sure if that means. I'm not either. Okay, here we have the scene, and we go to the render layer, and we get the eating room, the living room, the entry light, and the hue. And of course, for the hue, we get kind of nothing because the low sampling, and probably because we disable multiple importance. But the sun is exactly the same. It's killing everything, so it's horrible. But yes, we can denoise the sun. Let me enable again the things, because if not, we are not going to get a proper result in the lights. So let's enable multiple importance sampling again. And okay, multiple importance. Let's see if I can enable all at once. Yeah, great. And the sun, I don't know if it has, yeah, it's enabled. So let's render again. And since it's just 41 seconds, let's render to 1000 samples. Yes, the sun have multiple importance enabled. No, there is something, I think I'm going to send you this scene there, because there is something that is killing the render with the sun. I'm not sure what could be. Also, two other patches that we have in our build is that we have the new two new patches by Stefan Werner, also the equiangular sampling method, the new equiangular sampling method, and the new sampling method for the spherical lights. No mesh lights. No, yes, no mesh lights. Mesh lights would kill everything. I already learned this with Lukas Stockner in his talk in the World Summer Code. No, not World Summer Code, the Blender conference. Okay, here we have the scene again. And now we are going to go to, it's the same result, but at least we have a pair more of pixels here. Just a pair of pixels. Well, let's go to compositing. And I have here all the setup for the denoising of each pass. So if we go here, we can see the sun. Let me increase this. Here we can see the sun, and we can see the sky, and we can see, this is one light, but I'm not sure, and we can increase the light, this light, only this light. So this is the set alpha, and what is this doing? Ah, this has no light connected. Why? Because I use this is in, let me reconnect this. So we have the setting, for example, we have the eating table, the living room, and the entry light. Hello, Abma. And now, okay, we have the ceiling from the living room, and we can increase the power of this. So I'm not sure you have the exposure here. No, let me create the exposure node. It's just a mix node, a matte node, and we configure this matte node to power of 2, this to 0, and this should be multiply, and that's it. Now we create a group. This goes in the image, and this goes in the value, and the result goes here. So this is how you can create an exposure node here to increase the exposure after the rendering or in compositing. So we can go, for example, to the ceiling, and if we check this picture and we increase this, we get a lot more light. Of course, with this amount of samples, this is kind of crazy, but let's try it anyways. And now we can try the denoising, and we get this. It's cool. Super low in samples, but it's pretty cool. Have you heard that eCycles is working on a photo mapping system for cycles? No, I had no idea. I hope Matthew can implement a photo mapping system. It's cool. So, as you can see, we can do whatever we want. And when you have enough samples for the light, so for example, let's create another reroute here. Let's use the... So you can relight, completely relight this scene in compositing. And this is very cool because now we have proper clamping. So we get proper rendered results. We don't get like kind of crazy picture full of fireflies. It's the correct result what we get. So that's it. That's the second feature I wanted to show. And yes, we could pick the sun and let's mix, and we can pick. This is the sky. I hope this is the sky. What is this? Yes, this is the sky. And now we are going to mix the sun in add, and we can instead of the noise in the sky, we can use the sky with the noise, I mean, and we get way less noise from the sun. So it's a possible solution, but in the end, we are going to denoise the full scene anyways, so it doesn't matter. It really doesn't matter. Also, Stefan, this is a question for you. I don't know if you can answer this or here, or if you are still watching the live streaming, but I had to do one thing for the denoise to work properly with the textures. Hello, Satomonte. The problem is with the denoising albedo, and we spoke about that in the developer.org thread for the div for the OpenIntelliMate denoiser, and is that the denoising albedo we have is this one, and it's kind of white, super white. I don't know why. So someone proposed a solution for this that was doing this kind of maths, and with that we get this albedo that is working much better because we get the proper textures. So we can check the result. We can see the result with and without this change. Especially here in the table, you can see the texture in the table. But if we use the denoising albedo as it is out of the render, we don't get the texture. So I don't know if you know why is this happening, and maybe we can get these maths inside the denoising node, just so the actual denoising albedo, we don't have to change the actual denoising albedo if the Blender denoiser needs this kind of albedo. We can get this kind of math inside the denoising node, and we can enable or disable this kind of math because the denoising works much better with this maths with the denoising albedo. These are the maths, by the way. And the result for each of that is that it removes it subtracts 1.0 of power of the picture, and it takes the mass for that part that is subtracted, and it adds this part over the other part. So we get much better results. Great! The denoising passes were written with locus denoiser in mind, not Oiden. Going forward, if OpenIntelliMate denoiser becomes the denoiser of choice, we should change the albedo pass accordingly. But I think we should get, so we can get two denoisers, because in some moments, in some situations, the Blender denoiser works best than the OpenIntelliMate denoiser, and in other situations the Intel OpenImage denoiser works best. So I think we should get that. That's the reason why I mean that we can have the kind of modifications, or to have an alternate albedo for the OpenImage denoiser. So we have the denoising albedo, And this could be great because right now, if we enable the denoising data, we get a lot of unused data. So we get more memory. We use more memory when we are not going to use all those passes. So maybe we can get Blender denoising data and Open Intermediate denoising data. I don't know. It's something to talk about, I think, in the forums on in DevTalk or whatever. Okay, this is the second feature I wanted to show you. And we have the third feature that is kind of a surprise because it came a minute ago before the live streaming. And it's a super cool feature. Let me show you. So let's create a new scene. And let me configure this so I don't hide the... Okay, this, and now this, so I don't have the interface. Let me delete everything. So we have a plane, as always. Yeah, I've noticed when using denoising data, my renders get significantly slower. Yes. When you are doing a render for 20 minutes or 10 minutes, the difference in render time is not so big, but the difference in memory, it's important, because if you are rendering a scene that takes, in the CPU, takes like 54 gigabytes, like the scene in one of our latest projects, then if you increase the memory so much that you run out of memory. So for example, not 58 gigabytes, but for example, 63 gigabytes or gigabytes, I don't know how to say in English. And you enable the denoising data, and then you don't have enough memory in the CPU to work fast. So having something to optimize this, or even being able to enable or disable its denoising data pass manually could be great. I don't know, but it could be improved that way. So let's think we have, let me pick a sphere. We have this sphere, okay? And what happens when we want to generate randomization in the color or in the material? Okay, so usually we go to the shading. Let me open here the shading, the shader editor, and I'm going to create a material. So we have this here and shade smooth, and we have this material. And let's go and enable the real sky, the sky from Wolf. It's super cool. This sky is one of the best skies in the world. I like more this sky than the physical atmosphere. The physical atmosphere sky, it's cool, but it uses, I think it uses some kind of HDRI or something, because it generates way more noise than the real sky. Also, the physical atmosphere sky, this is the latest add-on, the newest add-on for a physical sky that is in Blender market. The physical atmosphere sky doesn't have an option to put the time of the day. So yes, you can change the azimuth and the elevation of the sun, but when you change the position of the sun, is not physically correct. I mean, when you do a daylight animation, you are going to need to fix the position of the sun manually, because the sun doesn't go in a straight line. So with the real sky add-on, we have the proper animation of the sun, and with the physical atmosphere, we don't have that kind of option, at least that I know. It could be a great addition in the future, and also it could be a great addition to improve the noise that the sky generates, because it generates way more noise. So coming back to the topic, let's enable subdivision surface, because I don't want shadow terminators. We have shadow terminators. Yeah, I know, fun. So we have this material. Hi, San Martin. And let's say I have this object and this object and this object and this object, and I want to generate a random color for each object. Okay, you know how can we do that. We go here and we go to object info, and we generate a ramp. Let me create a pair of separations, and we go to, well, not even needed. We don't even need this. We are going to go from red to blue and green in the middle. Okay, we have our colors, and we put here the factor, we put random, and we put color, and we get this. More or less, we can modify the colors. If we modify this, we can go to solid, constant, sorry, and then we can change this. So we get some values here. We can also divide the random. I don't remember if it was divide or multiply. But the main thing here is that we get different values for the colors, okay? And that's cool, and that's not something new. But what can we do if instead of having a lot of different objects, we have everything inside one object? So I go and I do this, and then suddenly, if we add the object info, we don't get the randomization at all. Let's put a color ramp here, so we get, like, if we duplicate the object, we get that randomization, okay? But that's not what we want. What we want is to get each sphere inside the object with a different color. And now, thanks to patch by, sorry, let me by Omar, but I want to remember the entire name. He's the author of the many improvements in the procedural nodes for cycles. Omar Emara. Thanks to Omar Emara, we now have another option. Can you turn on screencast for the keys? No, sorry. No, I don't have. I think I don't have the add-on installed. Oh, I have screencast. Is working? No, I think it's not working. So sorry, no, I don't have the screencast prepared. Sorry. So instead of using the object info, we are going to use another node that we have in the geometry, and now inside the geometry node we have random per island. Yes, random per island. Theoretically, what this is going to do is to analyze the geometry, and it's going to give us a random value for each piece of geometry that is disconnected, but everything inside the same object. It's something that we missed a lot in cycles, in nodes, because, for example, if you want to do a tree or grass, or you want to do a floor, a wood floor, parquet, I don't know how to call it, but a floor with different planks, and you want to randomize the planks, what you had to do in the past is to generate masks or generate a bunch of materials, so you can randomize the material assignment for a random number of planks, and then assign one material per group of planks. And that's what not great. It was super bad. And there were other solutions, but it was super uncomfortable. So now we have random per island. And if we go here, we get this. And yes, we get some kind of randomization. The good thing is that since the object is the same, the randomization is the same amongst all the objects. But we can also randomize this, but using the object info. So we can multiply this value by this value multiply. And then we get different values. Okay. Thank you for the Real Sky credit. Yeah, your work, Wolf, is very good. It's super great, and we are using Real Sky on a daily basis. So why not? It's super cool. So we can get more randomization like this, but right now there is a bug, and I'm not sure why does this happens. And you can see here that we don't get a random value. I removed the other randomization. We don't get a random value per island, but we get two values here, one value here, two values here, and I'm not sure if this is a fault. This is my fault because I should recompile everything from scratch. It's possible, or if this is a bug inside the actual patch. I already told Omar in the developer.blender.org, but it's not fully working yet. Nevertheless, we can go here and we can use this, and we get different values in different objects. We can put this to ease, and here we have. So we have randomization of colors, randomization of values inside the same object. This is super cool. What is the slowdown? So theoretically, the slowdown is not so big. If I recall correctly, the slowdown is not big if the objects are, if the islands have a small amount of polygons per island. For example, a tree would be super fast. But if you have one object with 3 islands and each island is about 3 million polygons, for example, you are going to get the slowdown. So I don't see this as a big problem, because usually when you want this is precisely when you have a large amount of primitives, a large amount of islands, and usually those islands are small in geometry amount. So you can use this without trouble, and the slowdown is not going to be too big. What does it look with a monkey? With a monkey, it gets crazy because of the bug. Let's put the monkey here. It's Susan, is the king of the spheres. Let's go to the material. Ooh. And why not? Let's enable. Am I on CPU? Yes. Let's enable the denoiser. Why? Because we can. This is the only reason to enable the denoiser in this scene. Because we can. Thanks, Stefan. We can enable the denoiser. Okay, this was the latest feature I wanted to show you. It's a pity that we don't have the other. We can check how the other randomization goes. Of course, this can be improved a lot. Lol, wait, turn on smoothing and auto angle and see if it changes the pattern. I also turn it on, but not in the monkey. So let's say the smooth and normals. I suspected these two, but yes, it's changing the pattern. I thought it was not changing the pattern, but yes. But what about set flat? Yes, we can make it go crazy. Now to smooth, without the smooth, let's say the smooth. The random value is different. Yes, that's weird. There is something weird. Again, it could be because I have not revealed the full build, so I have to rebuild from the scratch, so deleting the cache of the build. So maybe that solves the problem, or maybe not. I don't know. But I already told Omar, and I hope he can solve this in no time, because I'm sure this should be a silly problem, a small problem. So it's pretty cool. It's pretty cool. Now I want to talk just a tiny bit, because we are 47 minutes and I don't want to go over 1 hour. I want to talk about why do we have this. Well, this, not the crazy monkey, but the custom build. Why do we have a custom build? Well, in production we need to be as fast as possible and as reliable as possible. That's obvious. And the problem with the, not the problem, but the fact, Ctrl-Shift-N. Why? What do I do with Ctrl-Shift-N? It does nothing. Sorry, Pablo, it does nothing. At least for me. So, the problem we have with the standard build, well, it's not a problem. The fact is the standard builds has to be super stable and has to be trusted by anyone in any situation. And that's not our case. We need the build to be stable for us, and we need the build in a way that we can trust the build. So for example, I can implement this feature, I can implement this patch, apply this patch. It's not the implementation, it's applying. I can apply this patch to our build, and if it doesn't work, it's not a big problem because we are not using that feature. We know that this is problematic right now, and we can avoid using it. So if developers implement this feature as it is right now in the master, a lot of people will start to use it, and will start having problems and trouble, and will start reporting bugs that should not be reported, because this is a bug, but this is a patch that is not applied in master, so it has not gone by review, and if it's not reviewed, then we cannot be sure that it will work in any situation. It has not passed the automatic tests, it has not passed many things, so we don't know if this patch may generate any kind of problem in other situation. It's something similar to what's happening to scramble distance and DirectSobol and adaptive sampling. So adaptive sampling needs review, DirectSobol needs review. It's not DirectSobol because right now the patch is DirectSobol, but I think devs are going to do a different blue noise dithering. I'm not sure if it's going to be the patch from Lukas, that is this one, or if it's going to be the patch, a new patch by any other dev. But right now we have DirectSobol, and the same with scramble distance. Why? Because they have to review this. They don't have time, and these features could be production proven and could be working for us and for many others, but they have to do the review. I really hope they can review at least adaptive sampling, scramble distance, and DirectSobol or blue noise dithering for 2.82. I'm not sure at all. I don't have many confidence on this because the time frame for new features is very small. But I really hope they can review this, because these features are the secret sauce for the speed up of cycles. There's nothing more than that. The speed up of cycles, there may be one or two not fixed, but tweaks that you can do, but the main speed up cycles come from mixing all these together. When you mix all these features together, is what it will give you a lot of speed up, really a lot of speed up. A scramble distance especially is going to be faster if you use the CPU. In fact, I had to disable in our build a thing you changed, Stefan, that made the scramble distance acceleration not useful. I don't remember what was the thing, because I had to make it to disable it, and I don't remember what it disabled. But I had to disable it, and scrambling distance was fast again. So this is it. This is the secret sauce to get fast cycles. So are devs aware of these brands? Yes, I think so. They know these brands. They use these brands. This is the same brands, by the way. This is the same brands that the old Theory Studios brands. The Theory Studios branch was stopped at 2.79, and I started my own branch in 2.80 to have a bit more of control what can I add or remove or anyways, but it's the same at the Theory Studios branch. So the patches are the same and everything is the same, but in 2.8. What I did is to apply a patch and to solve some conflicts when applying the patches, and that's it. Also, I had the help of Martin Felke, and I want to show you, since you don't know our build, I want to show you another feature we have in our build, because we have two new remeshers in our build, and they have proven to be super cool. You all know that the new remesher here inside the geometry remesh, we have the voxel and the quadriflow remesher, right? But what you don't know or what you don't have is if we go to the remesh modifier, we can enable, oh, look at this, we can enable the voxel option. And this is the actual OpenVDB remesher, but in a modified flavor. So we can go here and we can decrease the amount, and let me disable the render. I don't know why I wasn't at render. Let's put random and let's delete this. So as you can see here, we get the OpenVDB, but it's not destructive. So we get the modifier and we can use adaptivity, for example, 0.2, and it's everything in the modifier. We can also use another thing that is not going to work well with Suzanne, but let me show you. The smooth normals and the sharpen features. The sharpen features is going to try to respect some sharpen edges. So for Suzanne, it's not working very well. Well, it maintains the shape of the eyes and other things. 0.005, for example. Okay, it doesn't work with this. No. 3. No. So 305 was too small for Suzanne. So it tries to respect some hard edges, but if we go to a different model, for example, let's create a cube, and let's edit this cube and do this, and then this, and then this, and this. Okay, and we apply the modifier remesh voxel. We get this. Okay, and it's not bad, but 105. We get the same problem, that is that the sharp corners were softened, or softened, I don't know. And you can increase the resolution, but no matter what, the sharp edges are going to be softened. So if we enable the sharpen features, it tries to respect this kind of corners. And it's doing it. And now Blender crash. No, Blender don't crash. Well, Blender crash. And here it is. It respects the features, the sharpen features, as much as it can. And we can show the wireframe. So you can see that this is the remeshed geometry, but with the sharp corners, or most of the sharp corners, because for example here it has kind of a problem. It cannot maintain this corner. So we can go 0.05, let's see what it does. It cannot maintain this corner, but most of them are safe. So it's a cool feature inside the remesh modifier. We also have another, Rafalu, thanks for subscribing. We also have another option in the remesher. Let me create some particles. Yes, I said particles because I love particles. You know, I'm the particle guy. I really love particles. Even when I know the particles in Blender are pretty old, and I'm super excited by the new particles from Jack's Look, sorry. So let's increase the velocity, normal 10, for example. And we have this. Let's enable collision. Okay, damping 0.7, 0.3, 0.7.3. Okay, we have kind of a fluid. It's not a fluid because I'm not going to enable SPH, but we have kind of a fluid. So now let's increase this to 10,000 particles. And let's do 100,000 particles. And it's real time. No, 10,000. Yeah, 100,000 in real time. Well, we have this. Let's make this a bit smaller. And now what we have is that we can go here and we can put the remesser, because I think this should be, there's a discussion about if this should be under the remesh or it should have a different modifier. We can use the voxel remesh. What CPU are you using? I'm using 2990WX, a Threadripper, but in this case, I can show you if you want. In this case, the CPU is not so important. You can see that the threads are at 12%, 20%, so this CPU is doing nothing with these particles. Any CPU can do this. Okay, we can use the actual voxel modifier, voxel remesser, sorry, the OpenVDB, but we can enable particles. And if we enable particles, hey, we get particles. And there are some very cool things about this. First of all, we have filters. So we can go here, enable Gaussian, and we get kind of a fluid, much more similar to a fluid. Okay. Now we can do another thing, that is we can use CSG operands. This is super cool. And we can use, for example, cylinder, yeah, okay. No, and Y, 90 degrees. Let's apply the scale. Always apply the scale, please. Always apply the scale. This is super important. And with CSG operands, what we can do is that we can enable here CSG operands, and we pick the cylinder, and the cylinder suddenly gets added because we have union. But we can pick difference and check this. Hey, we don't have the part of the liquid because it's doing a Boolean in real time. This is super, super cool. Really, really cool. And let me hide the particles in the viewport. I think the remesh will work anyways. Display as known. Yes. And we can, of course, go here and say, no, I want to modify this. And let's say I want to see the liquid just inside the cylinder. So we go to the modifier and change the difference for intersect. And here we have the particles just inside the cylinder. We can decrease a bit more the voxel size. So we go to 0.05, for example, so we get more detail. And we have the particles just inside the cylinder. It's super cool. This is a super cool voxel remesser for particles. And you can simulate any kind of liquid now with particles in Blender, because SPH particles in Blender are amazing. We don't have enough control, of course, we need nodes, we need particle nodes, but the solver of the SPH solver inside Blender is amazing. We could get, it needs like a modernization. We need to be able to produce wet water. We need to be able to do different things, but the actual liquid solver is super cool. It's really, really good. So now we can do another thing, because this is one voxel, one remesser. Let's do another thing. Let's try this. So if I remember correctly, I'm not sure, but if I remember correctly, right now it supports motion blur. That is something important too. So we can get this. And we can go here Let's try the render. Let's hide the cylinder. Not the cylinder. Where is the cylinder? Here. Okay. And now let's enable motion blur. Remember, motion blur doesn't work in the viewport. I'm going to put the shutter 1. And let's see what happens. 50%. And render 200 samples. CPU performance 16 by 16. Okay, that's okay. And no, it has motion blur disabled. But no, the OpenVDB remesher doesn't support motion blur. But we have another option here in the remesher. That is the metable Sugamasta metabolism metable option for the remesher. And we don't have the CSG operands, that's the bad part. But we get this this option, and we can go here and check this wire size. This is the viewport size, 0.2 for example. We need to reduce it to get more resolution. Also the size of the particles, let's put 0.1, and we get this. It's faster, especially at this resolution. In some situations it's faster, in some other it's not faster. 0.1, it's going to be okay. And now we don't have also the filters from OpenVDB, but we can go here and put the smooth, and we can smooth here this a lot. Now we have kind of a liquid. And if we check this, okay, has a problem. It's like it needs to render. I don't remember how to solve this problem. Of course, you can bake this to Alembic. And now we get motion blur, but I'm not sure if the motion blur is correct. So this is something to be debugged or something. I'm not sure the motion blur is correct because I see this kind of motion and I'm not entirely sure. We can also do another test to see if the motion blur is correct. Let's go to the remesher and let's put 0.05. So we get like individual parts. Yes, as you can see, the motion blur is kind of weird. So Martin, we have to review this motion blur. Is not correctly working. Anyways, we have two different methods to render liquids or to remesh with the modifier. I'm not sure if the motion blur could be correct in compositing, maybe with the vector pass. Let me test this. The render is done. Now use nodes. We have the vector pass, and let's put vector blur. We have vector here, depth here, and image here. And no, it's not correct. You can see how the movement is going in a different direction. I don't know, we have to investigate this. So, SAC3D, calculate with GPU optics is possible or is only for rendering? What do you mean? The denoiser, the OpenVDB remesher, what do you mean? I'm not sure what you mean. So, we enable curved anyways. Now, those were the features I wanted to show you here. This build is available on Graphical. Let me show you. And I'm going to update the build later this night with the viewport denoiser. So you go to Graphical and you just have to check for Bone Studio Blender 2.82. And also you can build it yourself using our GitHub. You just have to find to search in Google for GitHub Bonemaster, and here you have the branch. If you don't know how to build Blender or how to build this and you want to build this, first go to the wiki page of Blender on how to build master, how to build standard Blender, make the build possible, and once you have the master branch built, you can go to the wiki in our GitHub, and here are some instructions on how to add this GitHub as a remote and how to use this to build Blender. There are some things that are outdated, like for example, there are some details here for the open image denoiser and other things that they are not needed anymore. So, but this is enough. So you can go here to the wiki, learn to build Blender, and then use these instructions to build your own version of Bonemaster. I'm going to do a Linux build because someone asked me if we are going to have a Linux build. We work on Linux, and in general, yes, we have a Linux build, but usually we build every time on each computer. It's faster than having to distribute the build. But we have also a static libs build that is thought for the render farm. And right now, the only build I can provide, and I will provide, maybe not tonight, but I will provide a Linux build, is the one that is supported by any version of Linux that works under glibc 2.27. So if you want to check what glibc version you have to write LDD. I don't know how to say this. Slash? No, slash is this one. I don't know. This with the option V, and it was not LDD. Sorry, I forgot how to check. Okay, let me check the history. And yes, here we have. Here you can see all my. But I did it last night, I think. U LDD U. For some reason, it's not working. Let me check this because LD okay, LDD version. Okay, that's it. And here you have your version of glibc. Okay, so anything built in this glibc version, we work in this glibc and future glibc versions. But if you have a Linux, an older Linux base, an older glibc version, the build is not going to work for you. That's it. It's a fact, and I can do a build in a virtual machine, but it takes like a lot because the virtual machine is slow. It's super slow. So I'm not doing that build because I don't have enough time. So if you have an older glibc version, you just have to follow the instructions here and build it yourself. And if you have 2.27 or newer, then the Linux version is going to work for you. So that's it. I think that's it for today. 1 hour, 11 minutes is more than enough. I hope you liked this live streaming. I hope you liked the new features we have in the Bone Studio build. Go download the Bone Studio build and go comment the patches. Go comment the developers, Lukas Stockner, Stefan Werner, Omar. I keep forgetting your surname, your second name. Omar Emara. Yeah, Omar Emara and Martin Felke and many others, because this is made by many people. But go pinch them, go poke them and say, hey, this worked great, but what if? And sometimes we'll ignore you because they don't have enough time to talk to everyone and to do everything that we want them to do, because they don't work for us, so they have priorities. But other times their priorities are in line with our priorities, so maybe this can help them to motivate to create or to improve a feature. And I can assure you that these features are amazing. Every patch I'm applying to the build is amazing, and really happy with how our version is coming. And I really hope to see those patches implemented in master soon. But until we have those patches in master, we have our build. So that's it for today. Please, if you liked the live streaming, subscribe to the channel, press the little bell so you get notified. Press the like if you liked it, press dislike if you don't like it, but if you press dislike, please comment and tell me what you dislike about the streaming. I always try to improve it. And share this live streaming so I can have more people watching the live streaming in English, because I stream about many things, about Manteflow, about particles, about anime. I will stream about rigging soon, about many things. So see you in the next live streaming, and thanks everyone. Now let me read. You were correct in the first place. Surname. Okay, it's the same as second name. So surname or second name. Yeah. Thanks, GGL6. So see you in the next live streaming. With my own build, I will gain better performance on my machine. Gregor's, I don't know. Theoretically, yes, because it's going to build in your CPU for your CPU. But in practice, I think the difference nowadays is very small. So I think no. You need to apply patches made by developers to improve the performance. Now, okay, let's go. Bye everyone. Thanks.